Okay, welcome. So today's video it's from section 15.4, addition and subtractions of rational expression. Most likely two videos. So let's start with a note. To add or subtract rational expressions, we need to have the same denominator. So in today's lesson, we're going to add expressions, rational expressions. Some of them will have the same denominator. Some of them will need to create common denominator by applying LCD, least common divisor. So, for example, okay, when you have 1/2 plus 1/2. So those two fractions are rational expressions. Here we're ready to add them since we have common denominator. We have the same denominator, which is 2. So what we're going to do, we copy 2 and we're just adding numerators. So the answer is 2 over 2, which is 1. Okay. That's the easy case when we have the same denominators. Or we may have expressions like this. 1/2 plus 1/3. So here we cannot add them because we need to get common denominator. So how are we going to do it? And I want to explain it on easy example, okay? So we need to find least common divisor of the number which you have in denominator, which is 2 and 3. Since both of them are prime, so your least common divisor will be 2 times 3, which is 6. So what we're going to do next, you're going to take your original fraction and you're going to rewrite it with the new denominator, which is your LCD. So we already have 1/2. So to get 6 on the bottom, I need to multiply top and bottom of the fraction by 3 because I'm creating equivalent fraction. And now I multiply. You have fraction times fraction, which means you multiply numerator and denominators together. 2 times 3, I already have that 6. And we end up with 3 over 6. Then you're doing the same work with 1/3. You want to create equivalent fraction which has 6 as a denominator. So to get 6 on the bottom, we have to multiply top and bottom by 2. And then we have 1 times 2. So 1/3 is the same as 2 over 6. So now when we create equivalent fraction, we'll go back to our original problem. 1/2 is the same as 3 over 6, plus 1/3 is the same as 2 over 6. And now when we finally have the same denominator, we copy this denominator and we're adding numerators. And the answer will be 5 over 6. So I explained what we're going to do in this section using easy fractions. Of course, we know rational expression, they're a little more complicated. Okay, so what we did, we add or subtract by combining the terms in numerators and then write the result over a common denominator. Okay, so I explained one example and I'm going to give you all the steps based on the example. Okay, so we don't need to write the steps. Okay, the easy one I will be explaining. So let's do example 1. Add or subtract rational expressions. Okay, so let's do easy case. 3 over 14 plus 4 over 14. Okay, so how are we going to add those two rational expressions? So let's write a note. Since we have the same denominator, they are equal, what we're going to do, add numerators together, simplify, and then write the result over the common denominator. Okay, so we're going to add numerators together, so 3 plus 4, and we're going to rewrite that over common denominator, which is 14. So we have 3 plus 4, which is 7 over 14. Okay, and last step, simplify. Okay, 7 over 14. Okay, 7 is a prime number. However, 14 can be break down to 2 times 7. So fractions, you guys know that you can simplify. We have 7 on the bottom, 7 on the top. So 7 divided by 7 will give you 1. So if there is no number in numerator, of course there's 1 over there, over 2. So 1/2 is our final solution. Okay, let's do B. We have 2 over 7D. Again, D, it's a variable, minus 9 over 7D. So here also it's a nice case because we have the common denominator. Both fractions have 7D on the bottom. So copy denominator once and simplify numerators by follow the operation. So you're going to take 2 and you're going to subtract 9 from 2. So we copy denominator once since we already have common denominator and we subtract in numerators. So 2 minus 9 will give you negative 7 over 7D. 7D means 7 times D. So you can simplify this fraction. 7 will cancel and you end up with negative. So there's negative what? Of course, it's going to be negative 1. If you don't have a number, it's always 1 over D. So that's our final solution, negative 1 over D. Okay, and let's do more examples. So far we're working with, let me just go back and fix that. Yeah. We're working with the rational expression which have the same denominator. Let's do example C. In C, we have x squared plus 2 over x plus 3 plus 4x plus 1 over x plus 3. So we have two rational expressions, okay? The good thing is that we have the same common denominator, which is x plus 3. So we're going to copy denominator once, and we're going to work with numerators. So we're going to add numerators together. So you have x squared plus 2 plus 4x plus 1. So again, note what we did. we copy denominator once, and we add numerators. Okay, so now you have to simplify numerator. So we have x squared plus 4x and 2 plus 1, that will give us 3. 4x plus 3 over x plus 3. Couple things about rational expressions. Rational expressions, they are like fractions. So you always want to keep them in the simplest form, which means you want to reduce them. You want to cancel repeating factor. So that's what's happening here. This is not your final answer. Okay, next step here will be factor numerator and factor denominator. Denominator is already factor, x plus 3 is prime. So now what we need to do, we need to factor the numerator. You see quadratic, that means you always will need to factor that quadratic. So numerator is x squared plus 4x plus 3, factor using, and I only teach you AC method, so I'm stick to the same method. A is equal 1, B is equal 4, C is equal 3. So I multiply A times C, and we're getting 1 times 3, which is 3. Next, I'm looking for two integers, which product is equal AC, which is 3. And the same two integers by addition has to give you B. In our case, B is 4. So 1 and 3 will work. Now here we have a nice case because the leading coefficient is 1. There's only 1 in front of x squared. So to factor x squared plus 4x plus 3, technically we're done here. You're putting two parentheses. You're splitting that x squared in half, so you're getting x and x. And then you have the first integer was positive 1, so we're putting plus 1. The second integer is positive 3, so we're putting plus 3. So when we factor this, that x squared plus 4x plus 3 is the same as x plus 1 times x plus 3, I'm going to replace the numerator with our factors. So let's go back to that problem right here. X squared plus 4x plus 3 over x plus 3. We factor that quadratic x squared plus 4x plus 3, and we end up with x plus 1 times x plus 3 over x plus 3. Also, what I recommended with rational expressions, that when you have binomial, which means two expressions together, keep them in a parentheses, so you guys will see what you can cancel. So numerator and numerator and denominator, they have the same factor, which is x plus 3. That means you can cross it out. They cancel. So our final solution, after reducing this fraction, we only end up with x plus 1, technically over 1, because there's no more factors in the denominator, which is the same as x plus 1. So this is our final answer. Okay, so this example was a little more advanced because we went back to factoring quadratic equations. So everything start applying, okay? Everything what you guys learning from section to section, it's coming back. We adding that. Let's do more examples. Let's do D. You have 4t minus 9 over 2t plus 1 minus t minus 5 over 2t plus 1. So I always recommend it, okay, to keep parentheses when you have expression, especially when you have to subtract, okay, because it's easy to make mistake. So look what happened. We have the same common denominator. So what we're going to do, we're just going to copy this denominator once. So we have 2t plus 1. So we're going to have one large fraction, and we're going to subtract numerators. So I copy the first numerator, 4t minus 9 minus, and again, even if you don't see parentheses, just attach them. That will help you avoid making mistakes. Minus t minus 5. Okay, let's start simplifying. So in front of 4t minus 9, there is no operation, so I'm just going to remove those parentheses. So this is 4t minus 9. Now look what happened. You're subtracting entire operation. So this is the same like having negative 1 in front of the parentheses. So what you want to do, you want to distribute that negative 1 to both, which will become negative 1 times t, it's negative t, and negative 1 times negative 5 will give you positive 5. So the major mistake what happened when students subtracting, they have that negative t correct, they subtract the first operation, but they forget subtract the second operation, which means subtracting second operation means change the original sign to the opposite. Okay, so please pay attention to that when you're solving problems. Like you see here, you had minus, but your final answer will be plus. That negative 5 has to become positive 5. Okay, now we're just combining like terms. So 4t minus t will give you 3t. Negative 9 plus 5, we're getting negative 4. And we copy denominator, 2t plus 1. Here we're going to stop. This is the final answer because there is nothing what you can factor from numerator, and there is nothing what you can factor from denominator. Okay, so that's the final solution. Okay, you only continue after simplifying if you see that your numerator can be factored. Now, next what I'm going to do, I'm going to give you the steps of adding and subtracting rational expressions with different denominators. So those type of examples, they require much more work. Okay, so this is where the action starts. Okay, addition and subtraction of rational expressions with different denominators. Okay, I will stop for a second. Okay, with different denominators. Okay, I will stop for a second. Okay, so let me give you steps, okay? Different denominators, that's what you guys will see more often, okay? So let me write the first step. Step 1, factor the denominator of each rational expression. Step 2. Identify the LCD. That's what we did in previous section. Least common denominator, least common divisor. Okay. Step 3. Rewrite each rational expression as equivalent expression with LCD as its denominator. You guys will see work. So far, this is everything what we did in the last section. Step 4. Add or subtract. Of course, depends of the problem. The numerators and write the result over the common denominator. Step 5. Step 5 is simplify. And by simplify, when you will do all those steps, you want to see if you can factor numerator and denominator if possible. And cancel. And cancel. Repeating factors. Okay, so all those steps will make sense. Now just do the example, couple examples, so we can practice that. Okay, so this is example 2. Okay, we're going to work with subtract. Because subtract, again, require more practice. We don't want to make that mistake and don't change a sign when we're subtracting. Subtract. Let's do the first one. You have 4 over 3x minus 1 over 2x squared. Okay, so like you see, right now I cannot just subtract numerators because we don't have common denominator. So I follow steps which I just gave you. So step 1 was factor each denominator. Okay, so the first denominator is 3x, so this is already factor. So 3x is technically the same as 3 times x. And the second denominator, it's 2x squared. So 2x squared is the same as 2 times x times x. So what we need to do, we need to find, and that's your step 2, find LCD, least common divisor, of 3x and 2x squares. Okay, So what's going to be LCD? So let's talk first about the variable which repeats. You have x squared and x. So you're going to select the repeating variable to the highest exponent. So we already took care of x's. And then when you're finding LCD, least common divisor, the divisor which can divide each of them, you can't skip any of the factor. So from the first denominator, you have still factor 3, which you have to copy down. And from the second denominator, you still have factor 2, which you can't ignore. So your LCD is 3 times 2, which is 6x squared. Okay, this is our LCD, least comma divisor. So we're ready to move to step 3. Step 3, rewrite each fraction as equivalent fraction with LCD as a new denominator. Okay, so the first fraction was 4 over 3x. We're going to build equivalent fraction, and the LCD of equivalent fraction has to be, we're going to build equivalent fraction with denominator, which is 6x squared. That's the LCD. So how are we going to do it? We learned that in the previous section. So look what happened. We already have 3x. We're trying to get on the bottom 6. So to get 6, 3 has to be multiplied by 2. Okay. And I already have x. So the missing factor will be x because I need to get that x squared. So again, 3 times 2 will give me 6. X times x is x squared. Okay. And what I multiply, what I have on the bottom, I also has to multiply the top of the fraction by 2x because we're building equivalent fractions. So like you see, 2x over 2x is just 1. So now, since we already have the denominator, so you will multiply 4 by 2x, and that will give you 8x. So this is our equivalent fraction. Let's save that. So I will go back to original problem, and I will rewrite 4 over 3x is the same as 8x over 6x squared. Minus, I copy this minus, and I need to do exactly the same work with the second fraction. Originally, we have 1 over 2x squared. Build equivalent fraction with denominator equal to 6x squared because this is our LCD. So the same idea, look what happened. We already have x squared, so it's good, but we need 6. Originally we have 2, so that means we need to multiply the bottom, the denominator, by 3 to get that 6x squared. Since I multiply my original fraction, the bottom part, by 3, I also need to do that on the top. So I'm building equivalent fraction. And now we just have 1 times 3. And that will give you 3 over 6x squared. So this is the second fraction. We build that equivalent fraction of 1 over 2x squared. So let's just go back to our original problem. And we're going to put here over 3, 6x squared. Okay. So super nice. Now we're ready to move to step 4. Step 4 will be subtract numerators because we already have that common denominator, and write the result over the common denominator. Okay, so here, let me just move this. We are right here. Let me just copy this one down. So we have 8x over 6x squared minus 3 over 6x squared. So we have common denominators. I copy the common denominator once, and I'm subtracting numerators. So I have 8x minus 3. And that's it. Step 5 was simplify, but here 8x minus 3, there is nothing which you can factor out. There is no greatest common factor. And 6x squared, we're just going to leave it the way it is. So this is your final answer. Okay, we're going to practice more. Have more examples for you. Okay, so let's practice. We're going to do example B. You have t over 12 minus t minus 2 over 4. So again, step 1, you have to factor denominators. So we have 12. 12 is the same as 4 times 3, and then you have 4. 4 is the same as 2 times 2, which is 2 to the second power. Let me just fix the first one. Let me just write the prime factorization. 4 is the same as 2 squared times 3. Okay, so step 2 is you have to find LCD of 12 and 4. So we already know that 12 is the same as 2 to the second power times 3. 4 is the same as 2 squared. So to find the LCD, you take the repeating factor to the highest exponent, since both of them are to a second power. So we'll just copy 2 to a second power. So we took care of 2's. And you still have one extra factor from 12, which is 3. You also have to copy this down and multiply. So the LCD, it's going to be 12. So technically makes sense because you have 12 and 4, so the least common divisor which can divide 12 and 4 is 12. Okay, so that's LCD. Sometimes you can skip that work if you guys just see that it's exactly 12. So step 3, I'm going to skip writing because I wrote this down twice, is to build equivalent fractions. Okay, so you have t over 12. Okay, you have to build equivalent fraction with the new denominator, which is your LCD. Okay, since our LCD will become common denominator, it's the same what we have at this moment, so we're not doing anything. Or you may think that we just multiply each by 1. So you'll end up with t times 1, which is t. So no change here. Now the second fraction, t minus 2 over 4, you need to rewrite using the common denominator, which is 12, and we need to build equivalent fraction. From 4, you want to get 12, so 4 has to be multiplied by 3. Since we multiply bottom part of fraction by 3, you also has to multiply numerator by 3. Now, I mentioned a couple times that when you have expression, especially binomial, keep it parentheses. So you multiply t minus 2 times 3. That means you're going to multiply 3 times t and 3 times negative 2. Or if you guys want to see better, you can just switch the order. This is the same as 3 times t minus 2 and use the distribution. 3 times t, it's 3t. 3 times negative 2 will give you negative 6 over 12. So we have it. Step 4, since our two original rational expressions have the common denominator, so we're just going to rewrite them and subtract. So again, we have t over 12, going back to original problem, minus the second fraction, which is 3t minus 6 over 12. Okay, so let's simplify. So now we copy 12 once and we subtracting. So you have t, and now be careful here. You subtracting expression, okay? So you have t minus 3t minus 6, which will become t minus 3t, and when you have a minus in front of the parentheses, you distribute negative 1, okay? So don't forget that this is like negative 1. So negative 1 times negative 6 will give you positive 6. You really have to be careful with that, over 12. Simplify, so that will give you t minus 3t, which is negative 2t, plus 6 over 12. And now, here, we can simplify better. So this numerator right here, you want to factor numerator, because you can do that. You have negative 2t plus 6. Okay, so factor numerator. What you can factor out, your GCF, greatest common factor, it's 2. You can factor 2 out. So you take your original negative 2t, you divide by GCF, which is 2, and that will give you negative t. And then you take your second original expression, which is 6, you divide by GCF, which is 2, and you'll end up with 3. So that negative 2t plus 6 can be rewrite as 2 times negative t plus 3, and 12 is the same as 2 times 6. So now you guys can cancel. You have 2 on the top and 2 on the bottom. So reduce that fraction and we'll end up with negative t plus 3 over 6. And that will be our final answer. So you always trying to simplify, okay? Reduce it. If you will end up like here, not a huge mistake if you will get here, but don't forget that your test right now is on Alex, so I won't be able to fully check your work. Again, you see that your numerator can be factor, do it, okay? Okay, let's practice more. So I'm showing you all the possible examples which are in the textbook, because I don't think that you will expect to see something different for homework. So let's do more, okay? 1 over x minus 4 plus negative 8 over x squared minus 16. Okay, so step 1, you need to factor each denominator. So x minus 4, it's prime, so you're going to keep it. There's no GCF, so you keep x minus 4. Now, x squared minus 16 is the same as x minus 4 to a second power. I'm sorry, x squared minus 4 to a second power. And I really hope that you guys now quickly can recognize the formula a squared minus b squared, which is the difference of two squares. Two perfect squares. Perfect squares. So this is the same as a minus b times a plus b. So in our example, you will have x minus 4 times x plus 4. Okay, so we factor the denominators. Step 2, find LCD of your denominators. So we have that x minus 4 and x minus 4 times x plus 4. It's just easier to find that LCD if you factor denominators. So what's going to be LCD? LCD will be, look what happened. We have x minus 4 here and x minus 4. So it definitely is x minus 4 times the factor which we didn't use, which is x plus 4. Okay, so we have it. That's the LCD. Next, what you're going to do, step 3, build equivalent fractions. Use LCD as a common denominator. Okay, so here, let's go back. The first fraction is 1 over x minus 4. So we build equivalent fraction with the denominator, which is LCD, which is x minus 4 times x plus 4. So look what happened. We already have x minus 4. So the missing factor is x plus 4. So we multiply top and bottom by x plus 4. So now we have that common denominator, and numerator you multiply here. So we have 1 times x plus 4, which is the same as x plus 4 over x minus 4 times x plus 4. That's our first equivalent fraction. Keep it. Now, the second fraction, originally we had negative 8 over x squared minus 16. Which is the same as negative 8 over x minus 4 times x plus 4. Again, don't forget that I already factored that denominator right here. So here, since this denominator is the same as LCD, there's nothing what we're going to do. So we don't need to build equivalent fraction because we have that common denominator. So now I just going back to our original problem, and I see that I have to add those two fractions together. So I take in my first equivalent fraction. Okay, so that's the first fraction. And of course, this is the second fraction. So the next step, step 4, fractions. Okay, so the first fraction is x plus 4 over x minus 4 times x plus 4 plus negative 8 over x minus 4 times x plus 4. Okay, nice. We have that common denominator, so copy the common denominator once. So we having x minus 4 times x plus 4 over, and we adding numerators together. So we have x plus 4 plus negative 8, and just simplify. So that will give us x minus 4 over x minus 4 times x plus 4. And look what happened. We have repeating factor. We have x minus 4 on the top, x minus 4 on the bottom. So that will cancel. And that will give you, again, since there's no factors left on the top, that means there is 1 over there, because you can always put 1 times, right? And on the bottom, you just have x plus 4. And that's our final answer. Okay, I'm going to stop here. This video is long already, and I will give you couple more problems. Okay, we'll go back a little bit to quadratic and factoring quadratic.